One of the most important ideas in physics is known as a conservation law. And what a conservation law is it's a pattern. And it's a pattern that nature follows and never breaks. That is, every time you check to see if nature's following the pattern, it definitely is. And the pattern that I'm talking about here is a conservation law. You're going to study two really important conservation laws. One of the conservation laws is known as the conservation of momentum. And the other conservation law that you're going to study is called the conservation of energy. So, needless to say, in order to study these conservation laws, you have to know what momentum is, and you also have to know what is energy. The thing about energy that's interesting is energy comes in many forms. So there are many forms of energy. But there's only one form of momentum. And momentum, the form that we're stuck with, there is no other form of momentum. It's just mass times velocity. But energy comes in many forms. And one of the most interesting things to do in physics is figure out what are all of the forms of energy. One of the forms of energy is called the kinetic energy. That's one of the kinds of energy that you're studying actually in this lab. And the kinetic energy is the energy associated with mass in motion. Another type of energy is referred to as potential energy. And there are actually many forms of potential energy. One form that you might be used to, but you've maybe not learned it with these kinds of words, is electric potential energy. It's energy stored up in a battery. So there's energy stored in a battery, right? So another form of potential energy is when mass is high up. For example, when all the books on your bookshelf are on the upper shelves, right? In some sense, or in a very real sense, there's more energy in having books on the upper shelf than books down low on the floor. And in fact, you might say that what you have to do in order to put the books up high is you have to do some work to increase their potential energy, right? There's other different kinds of potential energies. There is also an interesting energy referred to as thermal energy. And one way that you can add to the thermal energy is to cause things to slide against each other with friction. You know that when you rub your palms together, they warm up your hands, right? And that warmth is referred to as thermal energy. It's genuinely a form of energy, just like the kinetic energy is a form of energy. So there are these conservation rules about these two topics, momentum and energy. But because momentum only has the single form, its conservation is really easy to see. But because energy has lots of forms, its conservation, you can only see it if you know how to see all the forms of energy, right? Okay, so let me describe a little bit about what is a conservation law. So let me give you an example of a conservation situation, right? So here's a person, and let's say that they have $35, right? And here's another person, and they have $10, right? And this is the way the world looks before some sort of interaction. Actually, let me do this better than so. Before interacting, right? But what they do in order to have an interaction is they have a transaction, right? And here is what the transaction is. Let me draw in blue the fact that the person with $35 is going to give $5 to the person who has $10, right? So this is the transaction that's about to happen. And so after the transaction, let's figure out the situation. So after the interaction is finished, the world looks a little bit different. I've got these two people. And they're basically the same, except for the person who used to have $35, since they gave away $5, they're left over with $30. And the person that used to have $10, they now have $15. And so I know that this is no surprise to you. You know how to think about money. The reason that you know how to think about money is money has a certain pattern. And the pattern is this. It is always going to be true that if a person has $35 and they lose $5 of it, what they end up with is $30. And it's also true that if somebody has $10 and they gain $5, they end up with $15. That is, the way that money combines with a plus sign, right? You use pluses. Sometimes the pluses are actually negatives though, right? So you can have a transaction where you lose money. That's kind of like gaining a negative amount. But the conservation though, the pattern, the really interesting thing to say is that if you look at the total amount of money, the total amount is $45, and the total amount is $45, even though there was a transaction. But the transactions follow a conservation principle in the sense that no matter what kind of transaction happens, the total amount of money never changes, right? Individual amounts of money can change, but the total amount does not change. And the way that you say that is money is never created nor destroyed. It can only change ownership. And I'd like you to notice that you can, instead of money, you can actually use the word momentum. And you're going to study that in the lab today. And also, instead of using the word money, you could think about kinetic energy, or actually, you can't think about kinetic energy on its own. You can think about total energy. Right? So, so you're going to see this in the lab that you're working on right now?